Hello everybody, welcome to another exciting video of the data chapter of IGCSE. In this video, we are going to talk about data encryption, okay? And we will talk about what data encryption is, why do we use it, and how to encrypt data, okay? So we'll just discuss about that. So what is encryption, okay? Encryption simply means bringing some changes to the binary code of any data to make it completely unreadable. Okay, and because we know what changes we have brought, we can just reverse the changes to make the code readable again. Okay, so why do we just use it? Okay, why do we encrypt? Okay, encryption acts as a digital lock. It does not prevent hackers from stealing data, but it prevents them from understanding it. See, if I have encrypted a data and somebody steals the data and gets the data, they will not be able to read that. Okay, and whenever we want to just make it readable again, we will just use the same we will reverse the encryption process to make it readable again. Okay, and we just do encryption on sensitive information, okay, protecting highly confidential data like bank details, credit cards, and personal communication from active interceptions. Okay, so if you have gotten a website that asks the user for their passwords, for their bank details, for their personal information, okay, so you have to encrypt them to just add a level of security to that. Okay, we use it for digital trust, okay, to guarantee safe online communication, for providing users the confidence to conduct e-commerce on global scale. Okay, so if you do not trust a website and if there is just a risk of your data to be stolen, you will not do e-commerce and you will not do online shopping, things like that. Okay, and legal compliance. Okay, so see here, internationally we have gotten laws that mandate governments, hospitals, schools that they have to encrypt the sensitive data or personal data of the users. So we have to just kind of apply those rules and we have to work according to them. That's why we just use encryption. See, the anatomy of encryption, for example, okay, we have our plain data or plain text, the original readable message, and we apply an encryption algorithm on that with an encryption key. Okay, we will have just this encryption key because as we will need the encryption key back to reverse the algorithm that we have just applied on the data. Okay, and as a result we will have a ciphertext. What is ciphertext? That is just a scrambled unreadable output. And using the key, okay, we will just decrypt them back to make it readable. Okay, so decryption is just simply using the corresponding key to unlock the ciphertext to make it just readable again. Okay, so we have, for example, plain text of hello. We will apply an algorithm with a key to that and we will just get a ciphertext, for example, KHOOR. Okay, and that is just completely unreadable and ununderstandable by the reader. We have gotten mainly two types of encryption. Okay, symmetric encryption and asymmetric encryption. Okay, let's just discuss what they are. See, symmetric encryption. Okay, in symmetric encryption, the sender and receiver, both of them have a shared key. Okay, so you will just use the same key to encrypt the data and you will just use the same key to decrypt the data. Okay, so that the same key will be used. So it is fast and simple. But what is the problem with symmetric encryption? Okay, because you are just sharing the key that can just decrypt the data, so hackers can just get the key as well, and once if they just get the key and the cipher text, okay, so they can decrypt that back. That is a problem with the symmetric encryption. Okay, so see, then we have just gotten asymmetric encryption. Okay, in asymmetric encryption we have gotten two different keys. Okay, one, we have gotten public key that is just mostly used for encryption. For example, I'll share a public key with the people who want to send messages to me, that they can use that public key to encrypt their data. But for decryption, I will just use special algorithms that the same key cannot be used. I will just have another private key with me that can just decrypt the data. So here I'll just share the public key online with everybody. Everybody can just access that. But I will never share the private key. Private key will just remain with me, okay? And like this, we will just add more security, okay, to the file. In this table, we are just comparing the symmetric and asymmetric decryptions, okay? So see, in symmetric, we have gotten one shared key, while in asymmetric, we have gotten two linked keys, one public and one private. Public key is used for encryption and private key is used for decryption. Then after that, according to speed, okay, symmetric decryption is very fast, okay, and it needs low processing power. But asymmetric is slower because it has just gotten complex mathematical algorithms. Security of transfer, so we have just gotten some risk of interception. Anybody who just gets the shared key or has the shared key might be able to decrypt the data again and make it readable, okay? But in asymmetric, it is just highly secure, okay? Why? Because the private key that is used to decrypt data is never sent and never shared with anybody, okay? And what is the primary use cases here? Encrypting large volume of bulk data, because just, yeah, it is faster. And asymmetric, secure handshakes, okay? You will just send data which are just very sensitive. You will just do that for digital certificates and authenticating users, whether just the data is correct or is it correct user or not. Next, we will just discuss about some types of encryption, okay? The first one is the Pigpen Cipher, okay? How does it work, okay? We will just simply create some tables with 9 parts and some 2x shapes, okay? And we will just write our letters in each one of them. For example, yeah, A, B, C, D, E, F, G, H, I. And in the second one, yeah, we have gotten this dot. And this dot is not very important whether it's here or just there, okay? Just simply having a dot will differ it from the corresponding shapes of the first shape, okay? And T, S, U, V, okay? And W, X, Y, and Z with dots. And how do we just use it, okay? So instead of letters, we will just simply give them some shapes, okay? And having this table, again, they will just understand it and they will decrypt it back, okay? For example, see here, decrypt the following text using Pigpen Cipher. Learn with Sahil. So see here, the first one, L. L is this shape, okay? So we'll just, yeah, that is L. E. E is just a complete square. A, okay? A is that shape. And R is this one, okay? And N, okay? N is the square with a dot inside it, okay? So that is learn. W, okay? Then I, okay? This is I. T, H, okay? And S, that is just our S. A, then H, okay? We have gotten this shape here. And I, so we have gotten this shape here. And L, okay? We have gotten this shape here. That is just encrypting, okay? So encrypt the following text using Pigpen Cipher. So we just did that, okay? So I hope you have just understood that. And decryption, okay? Decrypt the following text using Pigpen Cipher. So in this one, see, we have gotten this Pigpen Cipher, okay? This is just the ciphertext, and we want to just decrypt it, okay? So the first one, for example, here, that is L, okay? Then, for example, yeah, this one, we have gotten I. Then we have gotten this shape, which is K, okay? Then the next one, which is E. Then A, okay? This one is N. And this one is D, okay? And next one, this here is S. Then this one is U, okay? Then the next one is B. Then the next one, that is S, okay? Then the next one, okay? And the next one is C, okay? Then the next one, again, that is just I. And the next one, again, that is just I, B, and the last one E. Okay, so that is just how we simply encrypt and decrypt using Pigpen Cipher. I hope you have just understood that. Then the next one, okay, is the Caesar cipher. Okay, Caesar cipher is just simply we will roll or we will shift the text. For example, if our key here is 3, so it means yeah, 3 places we have to just move the text. Okay, for example, A will just change to A, B, C, D. Okay, something like that. And at the end, if we just get here at the end, we will just roll back. Okay, we will wrap around or roll back to the first. And this is the flowchart for that. Okay, input message, input shift key, how that the number. Okay, examine character, see just each character. Is it a letter? So if it is a letter, yes, shift by key, whatever our key is, shift by 3, shift by 4. Okay, or if it is not, then pass unchanged. For example, it is space or anything, just we will not change that, and you'll just simply get the output. Okay, so this will just keep repeating, we will just keep repeating this thing. For example, see here, okay, the letter K is encrypted using a Caesar cipher with a shift of 4. Identify the resulting ciphertext. So, okay, so we have gotten this. So that is K. So K is here, 4 places. Okay, so that is 1, 2, 3, 4. So that will be O. See, that is just our correct answer. Clear? Or the cipher message below was created using a Caesar cipher with a shift key of -3. So this is the ciphertext, the result of the encryption. Okay, and we have to just here decrypt it and find the original plaintext. So the key was -3 while just encrypting. It means just 3 places we just went to the left. Now decrypting that, we have to just do the reverse operation. So we will have to just move it 3 places to the right. Okay, so the first one E. So E, 1, 2, 3. That will be H. Okay, let's just write. So that will be E will be H. Then the next one is D. Okay, so D, 1, 2, 3. So that is G. Then L. Okay, so L, 1, 2, 3. So that is O. Okay, then O, 1, 2, 3. That will be R. And the last one is Y. So Y, see here, 1. Then you will just wrap back. Okay, 2 and 3. So this will be B. So this is our original text. Clear? So I hope you have just understood the ciphertext.